If you watched the last video I did on cofunction identities, you'll know that you can explain all 12 of these identities using the relationship between the graphs of the sine and cosine functions. That probably explains why they're called cofunction identities. Co meaning together or mutual. In this video, I'm going to show you how to use the cofunction identities to solve some pretty complex problems in advanced trigonometry. We'll start by looking at an example. Given that the sine of pi over 5 is 0.5878, and I'm being asked to use a cofunction identity to evaluate the cosine of 3 pi over 10 to 4 decimal places. So I'm going to start by looking at the angle 3 pi over 10, because that's the angle that I'm trying to evaluate the cosine of. From this diagram, and using my understanding of fractions, I know that 3 pi over 10 is less than pi over 2. Think about pi over 2 as 5 pi over 10. 3 pi over 10 it must be less than 5 pi over 10. I know that 3 pi over 10 plus some angle must give me a right angle, or pi over 2. So we can write 3 pi over 10 as a difference between pi over 2 and some angle. We'll call that x. In the last video I did, I used this triangle to prove a few of the cofunction identities. I'm going to use this triangle again to help you understand how we're going to approach this problem. So we just discussed that 3 pi over 10 is less than pi over 2. And we concluded that because of that, I can take 3 pi over 10 and I can write it as pi over 2 minus some angle, this angle right here. Now if we're looking at a right triangle, the unknown angle that I'm interested in happens to be the other angle in the triangle. And we can solve for that angle simply by bringing the pi over 2 over to the other side and using some algebra, finding a common denominator, and solving for x. So I know from this analysis that if this angle is 3 pi over 10, this angle must be pi over 5. So you'll remember that I was trying to write 3 pi over 10 as a difference between pi over 2 and some angle x. I've just shown that 3 pi over 10 can be written as pi over 2 minus pi over 5. So how does this help me find the cosine of 3 pi over 10? Well, what I want to do next is apply a cofunction identity. I know the first identity in my list here involves pi over 2 minus some angle. It also involves the cosine ratio. I'm going to apply this cofunction identity to help me relate the given fact of sine of pi over 5 equaling this decimal number to the cosine of the difference between pi over 2 and the angle I just found, pi over 5. So I can set up an expression that looks like this. The cos of 3 pi over 10 I know is equal to the cos of pi over 2 minus pi over 5. Remember, we just showed that 3 pi over 10 can be written as pi over 2 minus pi over 5. From this identity, I know that the cos of pi over 2 minus pi over 5 can be written as the sine of angle x, in this case, angle x being pi over 5. So I should be able to simplify my expression into the sine of pi over 5. Well, conveniently enough, you'll recall that we were given that the sine of pi over 5 is 0.5878. So we can conclude that the cos of 3 pi over 10 must also be equal to 0.5878. Looking back at the triangle I used in my analysis, if I look at the cosine of pi over 2 minus x, I get a over c. Likewise, if I look at the sine of x, I get a over c. I've shown that in my solution here, using pi over 5 as angle x. Let's take a look at another example. Given that sine of pi over 5 is 0.5878, I want to use a cofunction identity to evaluate the cos of 7 pi over 10 to 4 decimal places. Now we can use a similar process here to solve this problem. This time, if I look at the angle I'm given, 7 pi over 10, using my understanding of fractions and radian measure, I know that this angle is bigger than pi over 2. I can represent 7 pi over 10 using this red angle. Remember, with these cofunction identities, we want to think about our given angles as a sum of pi over 2 in some other angle, or a difference of pi over 2 in some other angle. In this case, if I take pi over 2, or 90 degrees, and add some angle, I should get 7 pi over 10. I can represent that algebraically like this. 7 pi over 10 is equal to pi over 2 plus some angle. Solving for x using a little bit of algebra and common denominator work, I've determined that angle x is again pi over 5. Just like the last example, I want to find a cofunction identity that involves the sum of pi over 2 and x. It would also be helpful if the identity had cosine in it, because remember, we're trying to evaluate the cosine of 7 pi over 10. So I go to my list of identities, and I see this cofunction identity here. It involves the sum of pi over 2 and x, and it also involves cosine. So if I apply this cofunction identity, and the work I just did to find pi over 5 as my angle, I can say the cos of 7 pi over 10 is equal to the cos of the sum of pi over 2 and pi over 5. Now my cofunction identity tells me that this is equal to negative sine of angle x, again, angle x being pi over 5. So I can simplify my expression into negative sine of pi over 5. But remember, we are given that the sine of pi over 5 is 0.5878. Therefore, we can conclude that the cosine of 7 pi over 10 is negative 0.5878. So that was 2 quick examples of how to use cofunction identities to solve some pretty advanced trigonometry problems. There are of course more complex problems, especially once you throw in these reciprocal identities. But that's all I have time for in this video. Thanks for watching.